Example number 4. Okay, so in this example, now they're getting us to do this factoring, but again, they're giving us a hint here. They're saying that we should first remove GCF before we start doing the difference of squares. So remember, when you're given a question, normally you're not given that. So we should always follow these steps. So our steps always, the first step should be to find GCF or try to get a GCF. And the second step should be trying one of the 3 methods of factoring. So in this case, we're using difference of squares here, okay, because we only have 2 terms. So if you look at this example, part A, if you don't try to do the first step of GCF, at glance, it will look like you cannot do this question, because when you try to take a square root of 2a squared, you'll be like, that's not possible. And neither can you take a square root of 50. So when you look at a question like this, you're like, well, I can't do any difference of squares here. The fact is, yes, you can, because we are missing the first step that we should have been doing for every question, which is the first step always should be, if possible, take a GCF out. So when you look at this question, we know that we can take a 2 out. So we can divide out a 2. That leaves you with a squared minus 25. So when you look at it now, this bracket here is where you can do your difference of squares perfectly. So the 2 comes down as it is. That was already a GCF. That's not going to go anywhere. And what we will get from the difference of square is a squared becomes the square root a, and 25 gives me 5. And now you can see that we were able to do difference of squares. So the step 2 then is to factorize using, in this case, difference of squares. So our final answer is 2 times a plus 5, a minus 5. So remember, the GCF is a very, very important step throughout your factoring. That's why it's the first thing that we do. Okay? If you notice in example number or part B here, see if there is a GCF. So it doesn't mean that every time there will be a GCF. Some questions are just going to be the ones that you cannot factorize. But we should always try to see if there is a GCF. So here, there's a 3 that we can divide out. And the remainder inside is now the perfect candidate to again do difference of squares. Okay? So the 3 comes out as it is, and you get x minus 2y plus 2y. Okay? So same thing over here. Again, you can always pause the video, and if you would like to go ahead and maybe try this on your own, you're more than welcome to do that, or then join the video again. Okay? So the first one here again, this question is tricky, guys, because what happens is students will take a look at this and they're like, well, I can do a difference of squares on it. I don't have to do a GCF. So I'm going to do that first to show you. So what if you skip the GCF because you're like, well, I can do my difference of squares. So if you do that, you will get answer here. You'll get 12pq minus 2 and plus 2. So you were able to do difference of squares, but you'll notice that each of these factors can be factorized even more. That means you can actually take you can take a GCF from each one of them. So from this one, I can actually take a 2 out, leaving me with 6pq minus 1. And I can take another 2 out from the second factor. So again, I'm left with 6pq plus 1. So you had to go do GCF again anyways, and this time you had to do GCF twice. And these 2 and 2, because they're both numbers, you'll multiply to make them 4, and then you'll be left with 6pq minus 1, 6pq plus 1. So even though you didn't do GCF at the beginning, you had to end up doing GCF for each individual factor because it should be factorized all the way through. So this is okay to do, but what I would suggest is why not try taking a GCF right in the beginning first? That always makes things easier. So I would actually take a 4 out first, leaving me with 36p squared q squared minus 1. So what I did here is I took my GCF out first rather than doing it later, and then doing a difference of squares. So my answer would be 4, and the difference of squares, well, I will have here is 36 will give me 6pq, and minus 1 will give me plus 1, and then minus 1. The square root of 1 is just 1. So you can see the answers are the same, but it shortened the process a bit. Second, if you don't notice, sometimes you may forget and you may think I'm just going to stop right here, and then you would be wrong. So it makes sense to first do your GCF always. Okay, so in this last example over here, you could not even do this question if you don't take a GCF of 3x out. So when you take a 3x out, you're left with just x squared. And when you take a 3x out of from here, you're left with just -9. So now you can do the difference of squares in that binomial. It will give you x minus 3, x plus 3. Okay. All right. Try going through your examples.